Hi, good evening. Today we are going to deal with the analysis of a wall bracket. So let us start with the abacus. So click on standard explicit model. First of all, we have to set the work directory. Next, we have to create the part. Click on create part, 2D planar, shell, approximate grid size is 500. Click on continue. So this dimension is 100 and this dimension is 20 plus 80, 100, 100 plus 50, 150 mm. Next I am creating two fillets. Fillet radius is 20. Again another fillet radius of 50. Next I am going to create the inside circles. While creating the circle over here, you have to be careful because you have to start from this center point and you have to end the point vertically here. Okay, this endpoint should be here. I'll tell you later why it should be like this. So now dimensioning it, 10, again 10, and this is of radius 30. Okay, now our part is ready. Now click on property, create material. I am naming the material as steel, mechanical, elasticity, elastic, Young's modulus 2.1, E5, Newton per millimeter square, 0.3 Poisson's ratio. Creating a solid homogeneous section. Click on continue. Enable plane stress plane strain condition, 5 mm plane thickness. Click on OK. Assign the material, assign the section. Done. Now click on assembly, create part instance, make it independent. Click on OK. Click on step, create load step, static. Click on continue, OK. Create field output requests. Click on continue. Now let us check the question. What all are the interested variables? Maximum displacement and bond measure stress, strain and reaction force. So stresses, strain, displacement, reaction forces. Now click OK. Now go to load. Here I have to create the load. So while checking into the question, we can see that it's a valve bracket. These two holes, fixed points, and through this hole and at this point we have got a 10,000 Newton downwards. Okay, so here I have to create a load of 10,000 Newton. So click on load 1, click on create load, concentrated force, click on continue, and you have to select this point, and this point is only available if you create the circle as I have mentioned earlier while creating the drawing. You can see here, while creating this circle I have made the center point over here and I have dragged like this. For here I have created a center point like this and created the periphery point over here. While I am creating this circle, I have made the center over here and the periphery vertically downwards. Okay, now click on this point, click on done, and the component force, it's the force along y axis and negative direction, so minus 10,000 Newton. Click on OK. Next I have to create the boundary condition. Click on symmetry, anti-symmetry and caster. Click on continue. Now I have to select this. I have selected the both of the circles. So I have created the encaster condition. Now click on mesh, assign element type, click on assign element type, click on done. It should be plane stress condition, quad element CPS4R and trigonal element CPS3. Okay, now assign mesh controls, medial axis algorithm, click on OK. Now click on seed part instance, let it be 2 mm, click on OK. Now mesh part instance, yes, now we have got the mesh. Now let us go to job, create job, continue, click on OK, go to job manager, submit. Now you can see that the job has been completed successfully. So click on results. So now we can see that the stress distribution of this particular bracket due to this loading, it's the displacement profile, it's the reaction force, and it's the strain profile. Okay, now let us generate the report file. Click on report, field output, unique nodal, maximum principal strain, reaction force magnitude, 1 minus stress, and the displacement magnitude. Now setup, select ABAQUS bracket and click OK. Click on OK. So now we can see the report file generated. You can see that the total number of nodes is 2700 nodes. Now You can see that the element name is known, element size is known, number of elements. I'll get you the number of elements. In mesh part instance, yes, you can see that 2517 elements are there. Okay, you can see that in the message window, you can see that 2517 elements are there. It's 2570 elements. Number of nodes is 2700. Maximum displacement and maximum on message stress, maximum strain, maximum reaction force, all those are in this report file. The maximum values are displayed over here. So thank you.